In this lesson, we're going to look at the second backend Java bean for the rewrite of the prediction service. You see the code. It's in a working file called servlet wscode2.txt. You can see it's a standard POJO class, public class predictions. That's it. The really important parts are the three fields that you see at the top, lines 1, 2, and 3. The concurrent map, as mentioned yesterday, holds all of the predictions. In effect, this is our in-memory data store. We need it to be thread safe because, for example, two clients against the service might try at the same time to edit the same prediction. And of course, we can't let that happen. The concurrent map imposes the required synchronization, so it would prevent that from happening. The concurrent map is attractive because it's efficient. For example, it would allow one client to edit prediction 27 and another client to edit prediction 11. They could do that concurrently because they wouldn't be stepping on the same prediction. The atomic integer right below provides the lookup keys for the map. And again, we need to ensure that this is thread safe. So for example, two clients might try simultaneously to create new predictions. We have to ensure that those predictions get different IDs. And the atomic integer provides that required thread synchronization. The servlet context is a behind-the-scenes thing. It's needed, very important. It's basically the way the application talks to Tomcat. In this particular case, recall that the data for the predictions comes from a text file that's encapsulated inside the WAR file. It's the servlet context that allows the application to read from that file. So the code is a little bit grimy. It can stay behind the scenes. It doesn't really tell us anything essential about the web service. The constructor does pretty much what you'd expect. As you can see, it creates an empty concurrent hash map, and then it creates an atomic integer, which is going to generate the lookup keys. I want to jump now to the bottom of this file and review 2XML. This is unchanged from the earlier example of predictions, and it uses the tried and true XML encoder. Eventually, we'll generate more sophisticated XML, but for now, this is good enough. Finally, down here at line 5, there's a utility method called addPrediction. So the servlet that we're going to look at next would create a new prediction in a doPost call, and that prediction now needs to be added to the collection, and it's done in this little utility method. The rest of the predictions code we don't have to examine because, as I noted, it doesn't really add any essential knowledge to how the service works. The really important code for understanding the service we'll look at next. So this is yet another working file. It's called servlet wscode3.txt. And as you can see, I'm moving the cursor. This is our servlet. So I'm calling this the predictions servlet. It extends the HTTP servlet. There's a bunch of overrides. Some of them are more important than others. Let me just say a very quick word about line 1, the override of a init. A init is called by the servlet container once the servlet has been loaded into the container. So this is where in a servlet you would do constructor-like code. In this case, we create a new predictions instance. We just saw that utility class. And we also set the servlet context so that that predictions instance can then read the data file. Now, I'm going to pass over the rest of this code pretty quickly just so we can eyeball it this first time. We'll study it next time. So you can see there's the do-get. The logic is a little complicated. More on that later. There's the do-post. I've removed, for this session, the do-delete and the do-put, but they're there. The one that I want to focus on now is at line 14, you see do-trace. In addition to the CRUD verbs, HTTP supports various other verbs. Trace is one of them. Options is another one. Headers is another one. And our web service isn't going to support any of these verbs, so we need a way to handle requests that might come in with those verbs. So the strategy is straightforward. Basically, what the code does is it throws an HTTP exception. That's a special type of runtime exception, and it uses one of these symbolic constants. In this case, this is method not allowed, 403 at the HTTP level. There's also a utility function down here called sendResponse, and what I'd like to show you is how easy it is to generate JSON if requested. So the idea is this. sendResponse is called by doGet, doPost, doDelete, doPut in order to send something back to the requesting client. And the client, in a doGet request, can get either an XML payload, that would be the default, or a JSON payload if the client so desires. So to handle the JSON case, which is a special case, there is a Boolean argument in sendResponse. If set to true, we're going to return JSON, otherwise XML. So I'm using a very lightweight JSON library. It's a simple jar file that's encapsulated in my WAR file, very small, and you can see the line here, XML to JSON object. The payload is just the XML string. So this just takes an XML string, converts it to a JSON string. Once that's done, we reduce that string to a byte stream. We're dealing with networking. What's going over the wires are going to be bytes. So we get the output stream, we take the payload, we write it out as a bunch of bytes, we flush the stream, we have now sent our response back to the client.